The goal of this video is to not only go through another example to calculate probabilities based upon a sampling distribution, but it's also going to talk about what that probability would actually mean. So looking at this example, you really should be able to do the first two parts without my help because it's just like previous examples that we've done. So what I would actually do is recommend pausing the video here and then working through the first two parts and then checking with my answers to see if you get the same results that I do. Alright, so this 30% that we see should be our P that we're going to be using. And then this random sample of 140 would be the N that I'm using. So first, I would want to check my conditions. And what we should have found is that there was no known bias with our sample, and both N times P and N times 1 minus P were both at least 10. Now, since our conditions hold, I can actually write out my sampling distribution. So doing our sampling distribution, we should have found that the mean of our p-hat was going to be 0.3, and the standard deviation of our p-hat should have been about 0.0387, give or take some rounding there. So then p-hat will be approximately normally distributed with a mean of 0.3 and a standard deviation of 0.03873. In the next part, you're asked to calculate a probability. Again, I would pause the video and then check to see if it matches. Alright, so first we needed to find our p-hat, which was a set 28, out of our 140 that we had, so that should have been 0.2. Our mean of p-hat, just as above, is our 0.3, and my standard deviation of p-hat is 0.03873. I'm using all of these numbers to help draw my picture I have down here. So we know it's normally distributed from our sampling distribution. We know its mean is 0.3, so that's why I put that number in the middle. I then went out my three standard deviations, so I subtracted 0.03873 each time. I moved to the left here, so that's what those black numbers are. And then p-hat is our key number, so I put that where it belongs on our picture, so it's between 0.18 and 0.22. And then we want 28 or less, so the or less would tell me to shade to the left. So there's our first thing that we should get from our picture. From this picture, I should now know two different things. Since I'm shaded left, I'm going to be going straight to the table when I do find my probability, and I can definitely tell from my picture that I have less than half of that picture shaded. Because again, if I had everything to the left of 0.3 shaded, that would be 50%. I know I have much less than that shaded. So the next thing I would need to do is calculate my z-score and go to the table. So calculating my z-score, which is our value of p-hat, so our 0.2 minus our mean of 0.3, divided by our standard deviation, which we've already calculated, so our 0.0387330. We should have got a z-score about negative 2.58, which should make sense because we're the left of the mean, which is why it's negative, and we're between 2 and 3 standard deviations below the mean, so that's between our 2 and 3, and then negative. Took that value to my table and should have found 0.0049 from my z-table. Now, as we already mentioned, since my picture is shaded left, that value that I just found then is actually my probability as well. So I don't have to do anything to this value since we were shaded left. So my probability is 0.0049. And then the last part of this problem is to write out our interpretation of what that number means. Now, looking at our interpretation, we always start with what we were assuming. So we assume that Chantix was telling us the truth, or that they have a 30% success rate at 9 months. Us using that P of 0.3 is making that assumption. Then based upon that assumption, our probability that 28 or less of the 140 Chantix users are smoke-free at 9 months is our 0.0049. So that probability of being less than this 20% that we found in our sample. So again, everything up to here is not new, it's really just review. But now we want to talk about what does this probability really mean. So based upon this above probability that we just calculated, do we think that Chantix is actually over-reporting their success rate after the 9-month period? Why or why not? So the first thing we want to do is just sort of think about this yourself. And do you have a gut instinct based upon this probability we calculated, based upon this picture that we drew? What does our data show us? So let's talk through a couple different things here before I actually write out my answer. So first, they tell us there's a 30% success rate. We found in our sample that we had a 20% success rate, so our 28 out of the 140, which is, of course, less than what they reported. And in fact, it's 10% less. Now, is that 10% less a big deal is really our question here. So one of the things that's going to factor into if that 10% difference is a big deal to us is our sample size. And so how is our sample size affecting things? It affects that standard deviation. Because if I only had a difference of 10% and I was only sampling 10 people, that's only a one-person difference. So I want to take into account, well, I had 140 people that I was taking into account. So that standard deviation is helping us to realize how far away really is this 20% from this 30%. And so when we put those values on our scale, it helps us see how far away we are. From our z-score, we know that we're between 2 and 3 standard deviations, basically below where I should be. Right? This is where I should be if they really have that 30% success rate, and I'm down here. In fact, the probability of us getting this value or anything less was 0.0049, and that was assuming that they had a 30% success rate. So one of my first questions for you is, do you think that this probability is small? I think that most of us would agree that this probability is small. It's less than a 1% chance of happening. So what that really means for us is that our data, or anything worse than it, only had less than a 1% chance of happening if Chantix is telling us the truth, and it happened. So let's write this out together a little bit more formally and see if now the answer is obvious or not. So if Chantix is telling the truth, and by that I mean that 30% success rate, then the probability of having a sample proportion, or p hat, of 20% or less, because that's what we found in our picture, is very unlikely. Right, this is the fact that our probability was 0.0049. That's a very unlikely. So what does that mean? The first thing to emphasize, that's very unlikely to occur. And it did occur, right? I only got 28 out of my 140 that were smoke-free. So it did happen. So if my data that did happen is very unlikely to occur if they're telling me the truth, I actually don't think they are telling me the truth. So what that means for me is I do believe that they are over-reporting their success rate. So what that kind of overall takeaway is, if there is something that is very unlikely to occur under a certain assumption, and it happens, we generally are going to question that assumption now. It comes back to the same idea if you think about flipping a coin, right? Usually a big assumption we make about a coin is that it's a fair coin. So 50% heads, 50% tails. If I flipped it twice in a row and I got heads both times, what do you think? Is it still a fair coin? Okay, probably. That's only, 2 heads in a row. That's not that unlikely to happen. But if instead I flipped that coin 20 times and every single time it was heads, what would you think? You're probably going to see that coin because you don't think it's fair. You might think it has 2 heads on it. Why? Because that is so unlikely to happen if the coin is fair. Right, so when we calculate the probability of something happen under that assumption and our data strongly contradicts it because it's so unlikely to happen, that's when we're going to question that assumption. So one question you might have is, well, what's a small probability? In the next module, we're going to talk about what this small probability is more formally, but right now we're going to start with less than 10%. So if something has less than a 10% chance of happening, or in decimal form, then that would be 0.10, we're going to consider that unlikely to happen and question that assumption.